Can a single punch generate 1 ton of force? The question isn't hypothetical, it's physics. And the answer determines who wins the most debated fight in martial arts history. Imagine this: a boxing ring. No rules, 2 men, 1 question. Bruce Lee, 5'7", 135 pounds, the fastest striker documented in martial arts history. A human being who could generate devastating power from 1 inch of movement, who understood leverage, timing, and biomechanics with engineering precision. Mike Tyson, 5'10", 220 pounds in his prime, the most destructive heavyweight boxer of the 20th century, a man whose punches sent opponents unconscious before they hit the canvas, whose peekaboo style generated force that broke orbital bones and ended careers. Speed versus mass, acceleration versus momentum, the dragon versus the destroyer. 10 seconds. That's all it would take for physics to determine the outcome. But the answer isn't what most people expect. Because this isn't about who's tougher. It's about which fundamental force of nature dominates when two extremes collide. Let's start with the equation that governs all striking. Force equals mass times acceleration. F equals ma. This is Newton's second law. Inescapable. Universal. The foundation of every punch ever thrown. Bruce Lee's mass was fixed. 135 pounds, 61 kilograms. He couldn't change that variable significantly without sacrificing speed and flexibility. So he optimized the other variable, acceleration. Acceleration isn't just speed, it's the rate of change of velocity. How quickly you go from stationary to maximum velocity. And this is where Bruce Lee became an engineering marvel. His famous 1-inch punch demonstrates this principle perfectly. High-speed footage analysis shows his fist traveling from 1 inch away to full extension and impact in approximately 0.05 seconds. That's 20 punches per second capability. The acceleration involved is astronomical. Estimates suggest his hand reached velocities of 8 to 9 meters per second from nearly stationary positions. Apply the formula. Even with relatively small mass, when you multiply by extreme acceleration, you generate significant force. Calculations based on documented demonstrations suggest Bruce's 1-inch punch generated between 350 to 400 pounds of force. That's enough to break ribs, collapse solar plexuses, disrupt breathing. But the genius goes deeper. Biomechanical leverage. Bruce understood that the human body is a kinetic chain. Force originates from the ground, travels through the legs, transfers through hip rotation, amplifies through torso twist, and finally explodes through the arm into the target. Each joint acts as a mechanical lever, multiplying force at specific angles. His structure was optimized for force transfer efficiency, minimal wasted motion, every muscle firing in sequence, what engineers call summation of sequential velocities, each body segment adding its velocity to the next, compounding the effect. Additionally, kinetic energy equals 1/2 mass times velocity squared. Ke equals 1/2 mv squared. When velocity is squared in the equation, small increases in speed create exponential increases in energy. Bruce's strategy: maximize velocity, maximize kinetic energy transfer, compensate for lower mass through superior acceleration and biomechanical efficiency. This isn't martial arts mysticism. This is applied physics executed at the highest human level. Now consider Mike Tyson. Same equation, different optimization strategy. Tyson's mass, 220 pounds, 100 kilograms. That's 64% more mass than Bruce Lee. In the force equation, that's 64% more baseline potential with identical acceleration. But Tyson's peekaboo style wasn't about identical acceleration. It was about momentum transfer through superior mass and compact power generation. Momentum equals mass times velocity. P equals mv. Tyson's punches carried significantly more momentum simply because of his mass advantage. When that momentum transfers to a target, a human head for instance, the physics become brutal. His left hook to the body was measured at approximately 1,178 pounds of force in various boxing science studies. His uppercut generated similar numbers. Not because Tyson was faster than Bruce Lee, he almost certainly wasn't in terms of pure hand speed, but because he was dramatically heavier and trained specifically to put his entire body weight behind every punch. The peekaboo style developed by Customato is biomechanically brilliant. Tyson would bob, weave, close distance explosively, then explode upward with his entire body's kinetic energy concentrated into a compact, devastating blow. His legs would drive upward, his hips would rotate violently, his torso would spring like a coiled mechanism. All that mass, all that power, delivered through fists that had ended professional fights in seconds. Additionally, Tyson's punches had another advantage: durability and impact absorption capacity. His larger frame, denser bone structure, and heavyweight conditioning meant he could withstand impacts that would incapacitate smaller fighters. Boxing training specifically conditions the body to absorb trauma. Tyson's skull, neck, and core were engineered through years of professional training to take punches from other 200-plus pound heavyweights. From a materials engineering perspective, think of Tyson as a denser, more robust structure, more mass to absorb impact forces, more structural integrity to prevent catastrophic failure from single strikes. The peekaboo style also minimized exposure. Hands high, head movement constant, closing distance to negate reach advantages. This wasn't just fighting. It was tactical physics applied to human combat. So what happens when these two forces collide? Let's run the simulation. Scenario: open space, no ring, no referee. Real combat conditions. Bruce Lee's strategy would be speed-based attrition. Stay at distance. Use superior footwork to control range. Attack from angles Tyson's training didn't emphasize. Target vulnerable structures, knees, throat, eyes, that boxing rules don't prepare fighters to defend. Use kicks to maintain distance and disrupt Tyson's ability to close. His advantages: speed differential, kicking range, unconventional attack angles, training against non-boxing styles, lower center of gravity for mobility. Tyson's strategy would be pressure and closure, cut off the ring, or in open space, cut off escape angles. Weather initial strikes through superior durability, close to boxing range where his mass and power dominate. End the fight with combinations that Bruce's lighter frame cannot absorb. His advantages: 85-pound mass differential, professional boxing conditioning, proven knockout power, durability against professional heavyweights, experience against elite-level competition. The physics problem: can Bruce land enough high acceleration strikes to compromise Tyson's structural integrity before Tyson closes distance and lands one of his high momentum punches? Velocity versus mass in the force equation. Both generate significant force, but through different mechanisms. If Bruce lands first, and his speed suggests he likely would, his strikes target neurological disruption more than structural damage. A precise strike to the temple, throat, or solar plexus could incapacitate, regardless of size differential. But these require precision under pressure against a moving target, trained to minimize exposure. If Tyson closes distance, and his professional training suggests he could weather initial strikes long enough to do so, his mass and momentum advantage become overwhelming. One clean shot from Tyson carries enough force to cause severe concussion, structural damage to facial bones, or immediate knockout through brain trauma. The scientific reality: both men operate at the extreme ends of human capability. Both have paths to victory. Both face significant obstacles. Physics doesn't give clear advantage. It gives different tools optimized for different scenarios. The uncomfortable truth engineers understand. Small changes in initial conditions create dramatically different outcomes. Did Bruce land his first strike cleanly? Did Tyson slip it effectively? Did the fight happen in a phone booth or an open field? This isn't a video game with stat comparison. This is chaos theory applied to human combat. Here's what the physics actually tells us. Both strategies work. Both men represent the pinnacle of human martial capability. Both understood force generation at levels most fighters never reach. Bruce Lee optimized acceleration and biomechanical efficiency to compensate for lower mass. Tyson optimized momentum transfer and structural durability to leverage superior mass. Both approaches are scientifically valid. Both have documented success. The question isn't who would win. The question is, does engineering solve street fights, or do unpredictable variables, psychology, environment, luck, override pure physics? If you watched our Jean LaBelle video about the man who made Steven Seagal unconscious, a grappler who proved size matters in certain contexts, you know that style matchups create complexity physics alone can't solve. What do you think? Does F equals ma determine outcomes, or is real combat too chaotic for equations? Drop your analysis below. Subscribe for more physics-based martial arts deep dives. Engineering meets legend. Let's solve this together.